Hello, students, future engineers, subscribers, and viewers. Here is another problem in trigonometry about solutions to triangles. And we apply the law of sines here, purely the law of sines. And we consider possibilities of ambiguous case for the law of sines. So solve the triangles with given elements using only the law of sines. So for first part, A is 4.6, so that means we have to report our answers to two significant figures because of this given information. Two significant figures, four significant figures, for this case, four significant figures, E, uh, three significant figures, and F, four significant figures, or three significant figures, but in decimal form. So for part A, side A is given, angle A is given, and B is given. So the third angle can be computed by the fact that the sum of the interior angles of a triangle is 180 degrees. So this is our guide figure. So opposite to angle A is side A, B side small b, and C angle C side small c. And remember the fact about triangles that the longest side is opposite to the biggest interior angle and the shortest side is opposite to the smallest interior angle. And that the sum of the shorter side should be greater than the longest side. And for the formula, A over sine angle A equals side B over sine angle B equals side C over sine angle C equals the diameter of the circumscribing circle. So for part A, we have side B over sine 60 degrees equals 4.6 as to sine of 45 degrees. So 4.6 as to sine of 45 degrees equals B as to sine of 60 degrees equals C as to sine of angle C. So for this equation here, I'll solve this in detail first. B is 4.6 sine 60 over sine 45. And using your calculator, although 60 and 45 degrees are common angles, this is calculator aided. Sine 60 is square root of 3 over 2. Sine 45 is square root of 2 over 2. You may not use the calculator or you will not be allowed to use a calculator, but I'm just giving you the exact value of sine 60 square root of 3 over 2 and sine 45 square root of 2 over 2. So computing for B, B is 5.6 to two significant figures also because of this given value. Then we solve angle C first as 180 degrees minus 45 degrees minus 60 degrees. So angle C is equal to 75 degrees. So having found angle C, then we use this leftmost side of the equation and this rightmost side of the equation. So 4.6 over sine 45 degrees equals side C over sine 75 degrees. Therefore, C is 4.6 sine 75 degrees over sine 45 degrees. And so as I said, I solved it in detail first. So using your calculator there, C is equal to 6.3. Let's proceed to 2B. This time side C and angle opposite it given, and angle A. So we can solve side A first. From A over sine 30 equals 88 as to sine 120. So this time let's solve for A directly. 88 sine 30 using your calculator over sine 120. So A is equal to 51 to two significant figures also because side C here is in two significant figures. Then having found A, we'll solve for angle B, which is equal to 180 degrees minus angle A minus angle C. 180 degrees minus 30 minus 120 degrees. So angle B is also 30 degrees. So equal to angle A, therefore and the side is the same as side of A, which is 51. So by sine law, B as to sine 30 degrees equals 88 as to sine 120 degrees. So B is indeed equal to 51. Then we proceed to part C. This time, given side 24.46, angle opposite given also. So we'll solve for side B first. So 2C 24.46 as to sine 34.16 degrees equals side B as to sine 71.25 degrees. So solving for B, use your calculator there. 24.46 times sine 71.25 degrees over sine 34.16 degrees. So B is equal to 41.25 units. Then let's solve angle C. Angle C is 180 degrees minus 34.16 degrees minus 71.25 degrees. To four significant figures, angle C is 74.59 degrees. Then sine law to solve for side C, because C has been found. So there's only one triangle for these cases here. There may be no triangle, or there may be two triangles depending on the situations. Because the two angles are given, then definitely there will only be one value for the third angle and one value for the third side, of course. So sine law 24.46 as to sine 34.16 degrees equals side C as to sine 74.59 degrees. So C is 24.46 sine 74.59 degrees over sine 34.16 degrees. So side C is 42.00 units. Then let's proceed to 2D. This time it's side C and angle C given. So let's solve for side B first. So B as to sine 48.62 degrees equals 53.25 as to sine 61.45 degrees. So 53.25 times sine of 48.62 degrees divided by sine 61.45 degrees to four significant figures. B is 45.49 units. Then angle A is 180 degrees minus 48.62 degrees minus 61.45 degrees. Then 61.45 degrees. So angle A is equal to 69.93 degrees. Then let's solve for A. A as to sine 69.93 degrees equals 53.25 as to sine of 61.45 degrees. So side A is 53.25 times sine 69.63 degrees over sine 61.45 degrees, and it is 56.94 units. Then part E to three significant figures. We have A angle C and B given, so we cannot apply sine law directly. We still have to solve for angle B. So angle B is 180 degrees minus 73.2 degrees minus 23.8 degrees. There are two possible values of angle B. If the result is acute, then the other possible value would be its supplement. Remember that sine of theta is equal to sine of 180 minus theta. So sine of angle B is equal to sine of 180 degrees minus B. So B is 83.0 degrees. The other possibility is it is 180 minus 83. So it is also possible that it is 97 degrees. But let's stick to this first. A as to sine angle A equals 2.3 as to sine angle B equals C as to sine 23.8 degrees. So using this equation here, A is 2.3 sine 73.2 degrees over sine 83 degrees. So A is 2.22. Then for side C, C is 2.3 times sine 23.8 degrees over sine 83. So C is 0.935. Then if we consider the other possible value of B, which is 97 degrees, then it should not be possible because the given two angles are already fixed in value. So this must also be fixed in value. Sorry for the explanation later, unless there's only one angle given. So the third angle is fixed because the two angles are already fixed. So this will be the solutions. Let's proceed to F. We have two angles given and side which is opposite to angle B. So again, there is only one triangle for this case. There is only one possible value of angle C. So by sine law, A as to sine of 52 degrees 42 minutes equals 408 as to sine 75 degrees 36 minutes. So for those who do not yet know how to express an angle in degree minutes, so there's a mode there, just degree. You just type 52, then degrees, then 42, then same degrees, then it will automatically be in minutes. Same is true with 75 degrees, key the degree key and press 36, then same key in degrees, but it will automatically be in minutes. So side A is 408 sine 52 degrees 42 minutes divided by sine 75 degrees 36 minutes. Solving for A in degree minute for in units, therefore 335 minutes to three significant figures. Then let's solve for angle C, which is equal to 180 degrees minus angle A 52 degrees 42 minutes minus angle B, which is 75 degrees 36 minutes. So this angle C here is equal to 51 degrees 42 minutes. Then by sine law to solve for side C. So C as to sine 51 degrees 42 minutes equals 408 as to sine of 75 degrees 36 minutes. So side C is equal to 331 units. So that's it for this problem. I hope that you were able to follow the explanations and the solutions.